So we're going to talk about graphing sine and cosine functions with what we call amplitude and period changes. And we're going to start by just graphing a regular sine function. So f of x is equal to sine of theta. And what we're going to do to generate this is we're going to take a look at the unit circle and use specific coordinates from the unit circle to do a graph. So here's what I'm going to do. I'm going to take and create a horizontal axis that has the angle theta on it, and the vertical axis is going to describe the sine of theta value. All right. Now, typically, it's easiest to do this when our numbers are clean. And when I mean clean, I mean integer values. And on the unit circle, we know that all of our integer values of 1s and -1s happen at quadrant spots. So if I start at 0, then go to pi over 2, pi, 3 pi over 2, 2 pi. And I can keep going from there. I can go 5 pi over 2, that's 2.5 pi. 6 pi over 2, or 3 pi, etc., etc. I can go forever. Now I'm going to take and plug in 0 to the sine of theta. What is the sine of 0? Well, I'm looking for the y value. That's 0. What's the sine of pi over 2? I'm looking for the y value. That's 1. What's the sine of pi, which is right here? Sine of pi is just going to be 0 once again. Sine of 3 pi over 2, the y value is -1. Sine of 2 pi, y value is 0. Sine of 2.5 pi, which is right up here, once again is 1. Sine of 3 pi is 0, etc., etc., etc. So our graph looks something like this if we were to connect the dots in the right fashion. Now, within this, you see that this graph kind of repeats itself over a period of time. Notice if I start at 0 and go to 2 pi, it starts all over again. If I start at pi over 2 and go to 5 pi over 2, it starts all over again. If I went from pi to 3 pi, it again would start over by going down. So it repeats itself over and over again. We call these periodic functions because they repeat. And the time it takes to repeat is called the period. So in this case, it repeats from 0 to 2 pi, and 2 pi is the period of this graph. And they say that if you take a snapshot of one piece that is in fact the period, that's called a cycle. So from here to here is one cycle. Or I could say from here to here is one cycle, because it's a snapshot of a period. All right. Now, if we were to graph cosine, I'd do the same basic thing. Here's my axis. Start at 0, go to pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and I can keep going as long as I wanted to. Now, this time we're going to graph the cosine values vertically. And when I do that, I'm looking for my x values. So at 0, my x value is 1. At pi over 2, my x value is 0. At pi, my x value is -1. 3 pi over 2, my x value is 0. 2 pi, my x value is 1. 5 pi over 2, x value is 0. 3 pi, x value -1. So this graph looks something like this here. One thing you can also notice is this is going to go forever and just keep moving up and down. It'll keep going in this direction, but it can also go backwards in this direction. So I could go to negative pi over 2, and at negative pi over 2 we'd be rotating this way, right? And I would get an x value of 0 there. So it goes in both directions on and on forever. In other words, its domain's all real numbers. Now, in general, every sine and cosine function can be written in this form. Just like we had our parent functions written in another form, general equation for sine and cosine is very similar, where we have this a is equal to sine or cosine of k theta plus c plus h. All right? And in this case, a acts like our amplitude, and you would think it acts a lot like your y multiplier, just like it did in the other functions, and certainly it does. K is what's called a x multiplier, just like it was before, and what it does is it changes the period of the graph. And we'll find out that, in essence, if you want to calculate the period of a sine or a cosine graph, you need to take 2 pi over the k value to get that period, or if we're using degrees, 360 over k will get you that period. Now let's go ahead and graph some of these while we calculate these new periods and amplitude changes. So now we'll take and graph these three functions on a single graph. Let's graph sine first. Here's a sine graph, one period of it. And I have my, what I call nice little intervals thrown in here. And in this case, our amplitude, since we're going from 1 to negative 1, is just 1. Now, if I were to take and change my amplitude to 3, we'll do this in blue, all right? Then instead of being as high as 1 at pi over 2, I'm now at 3. If I multiply 0 by 3, I'm still at 0. And if I multiply negative 1 by 3, I'm at negative 3. So this graph is going to be roughly 3 times as high as the other. But nothing else will change because it's only a y multiplier and not an x multiplier. Now if I multiply all my values in this case by negative 4, then that means a 1 times negative 4 is negative 4. So that puts my graph down here. 0 times negative 4 is still 0. So all those 0 values remain where they are. And negative 1 times 4 is a positive 4. And that will go up here. So the red graph represents negative 4 sine of theta. Like so. Okay, now we're going to mess with our period change, and you'll notice in each of these we have a k value. In this case, k is equal to 2. In this case, k is equal to 1/3. And in this case, k is equal to pi. So we're going to calculate the periods in all of these. In the first problem, it's 1, so our period calculation is 2 pi over 1, or 2 pi. In the second problem, I have 2 pi over k, which is 2 in this case, so my period is pi. In this case, I have 2 pi over 1/3, so in this case, the period is 6 pi. And in the last case, I have 2 pi over pi, or a period of 2. Now, I'm going to graph each of these separate instead on the same graph this time, just to show you what's going on. Now, in all of our graphs, you'll see something similar, that all our clean values, we're graphing cosine, so I better not do that. All of our clean values happen at a x or y axis point, if you will, or at the end of a quadrant. So we had it at pi over 2, pi, 3 pi over 2, and 2 pi. And the graph looks something like this, rough sketch. Now, if I were to take and graph this next problem, what I'm going to do is I'm going to notice that I have 1, 2, 3, 4 quadrants that this was divided into. And that's going to be the same for all cosine functions with one period, is that period is going to be split up into 4 even sections. So what I like doing is I like talking about intervals. In this case, we have a period of pi, and if I want my intervals, since I have 4 quadrants, I'm going to take and divide my period and divide that by 4. So in this case, my interval is pi over 4. So what I'll do is I'll start out at 0, then go pi over 4, because that's the first interval. Pi over 4 away is my next, which is pi over 2. 3 pi over 4, because I'm adding pi over 4 each time. And pi. Then what I'm going to do is I'm just going to graph my regular cosine function, because what I've done is I have multiplied my x values by what's changed, and now I'm graphing my original function the same way it was graphed before. And we can check these values real quick by plugging a number in. For instance, if I plug in pi over 2 to this function, then I'll have 2 times pi over 2, which is pi, and the cosine of pi is -1. So it checks out. All right. Now, if I want to graph the next one, I'm going to do something very similar. I'll go ahead and take a look and find my intervals. So I know my period in this case was 6 pi. And if I want my intervals, split it up into 4 equal sections, I'll take 6 pi over 4 and get 3 pi over 2. So essentially, I've got this x multiplier extending my values, because we're dividing by a third, or in this case, multiplying my x's by 3. So I start at 0, and if I was to multiply that by 3, that's what I would get. My first interval is 3 pi over 2, which makes sense, because normally my first interval was pi over 2. Add 3 pi over 2 to that, I get 3 pi. Add 3 pi over that, and I get 9 pi over 2, which is 4.5. Add 3 pi over 2 to that, I get 12 pi over 2, which is 6 pi. And this is going to be one period of cosine. So once again, I take and graph the cosine function going through each of those intervals. And there's my new graph with my x multipliers all in there. But nothing else changed. Finally, let's take and say, well, if my period is equal to 2, and my intervals will then be the period divided by 4. So my intervals in this case are going to be a half. This is a little bit tougher to see, because my x multiplier in this case is going to be 1 over pi. So I now will take and start at 0, add a half to that, 1, 3 halves, and 2, and that's going to be my period of cosine. So again, I start up, move down, and graph my normal cosine graph with my new x intervals. So you can't really see visually, but if I were to put all these on one graph, you would see how this is stretched horizontally from graph to graph. So what we'll do now is we'll go ahead and combine both of these within one graph. Now, we know we're graphing sine in this case, so we're going to be graphing the y values. I want to find my period first. And we can rewrite this as 3 sine of a half theta. So now I know my k value is a half, so 2 pi over a half will be my period, which is 4 pi. If I want my intervals, I take 4 pi and divide it by 4, which gives me intervals of pi, and I know I have an amplitude of 3. So I'll start at 0. I usually like doing that. And then I'm going to take and make intervals of pi from there. So I start at pi, 2 pi, 3 pi, and 4 pi. And I'm going to graph my regular sine function. Normally sine at 0 is 0. If I multiply that by 3, it's still 0. Sine of my first interval, if we look at our unit circle, would be at 1, 0, -1, 0. That's usually my intervals. So instead of being at 1, I'm now at 3. I go back to 0, go down to -1, and back up. And once again, this travels from 3 to -3 on my interval, or I'm sorry, on my amplitude. So in this problem, once again, we'll identify our amplitude, which is 5, but we have to remember we're multiplying by a negative. Period is calculated by taking 2 pi over my k value, and k in this case is pi over 2. So that's equivalent to 4 intervals. We take period, divide that by 4, so I have intervals of 1. If I graph one period of this, I'll go from 0 to 1 to 2, 3, and 4. And then I'm going to graph a cosine function, which normally starts at 1, but will now start at -5. Because I'm doing an y multiplier of -5. Then I would go to 0 from there, up, back to 0, and down. And there's my graph. Once again, traveling from 5 to -5 on an amplitude. So we'll switch gears a little bit. Rather than graphing now, we're going to take and write an equation of a cosine function with an amplitude of 7 and having a period of 4, or pi over 4, sorry. So we're going to need to find the k value if we're going to write the appropriate function. We know the period is pi over 4, and that's equal to 2 pi over my k value. So now I have to solve for k, and in order to do that, I'll take and do cross product. So pi k is equal to 8 pi, and k then is equal to 8. So now I can write this equation. I can say y equals Since my amplitude is 7, I say 7 cosine of 8x. And there's my function. In the next problem, we'll do this with a degree measure, although we haven't done much of anything in degrees. Typically in trig books and such, they'll get away from degrees and start using radians. So that's what I've been doing. But we'll continue anyways. We know a period of 540 is equal to, usually it's 2 pi over k, but since we're in degrees now, we'll go 360 over k. Therefore, in order to get k, I've got k is equal to 360 over 540. And in this case, we can reduce that. 360 divided by is going to be 2/3. So that's my k value. I said I had an amplitude of 2, so this is y equals 2 sine of 2/3. I can go theta x, it really doesn't matter. I'll go 2/3 theta. And then finally, we're going to take and write the equation of a sine graph given this picture here. Now, the important thing to do on this problem is to identify what your period is going to be. So in this case, we know a period means you're taking a look at one cycle. So if I go from here to here, I notice this graph is going to repeat. Also, I notice that a sine graph usually goes up and down. So what this says is I'm multiplying by a negative. I'm traveling between 3 and -3, so that means I must have an amplitude of 3, but it's got to be negative, and I know it's a sine graph because they told me so. Now I just have to figure out how to get my k value from here. But like I said, I know my period is equal to pi. So if the period is equal to pi, pi equals 2 pi over k for a sine graph. So therefore k is equal to 2. So y equals -3 sine 2 theta is going to be my solution. And that's all we've got today. Do your My Math Lab, and we'll see you tomorrow.